So we had a small recording failure there. Anyway, the point was made that this thing worked reasonably nicely, and the next thing I wanted to do was add the materials. So I've filched this from another file. I'll just go through it the way I just did. So the strain softening behavior of the material is expressed through a number of tables. Here you can see the command table, the name, and then you add the elements. So the X values of these tables are the plastic strain values. The Y values are whatever they happen to be, depending on where you're going to assign them. So in this case, I've got coal cohesion, and you can see I've set up a number of variables here that help me to define that. So my initial cohesion is set to a high value, and then I've got a residual value with a very low value of 0.01 MPa, and that occurs over the specified plastic strain scale, which is in this case is 0.01. The friction starts off at a high value and then increases even further. That's cohesion weakening, friction strengthening. It's 2e minus 3 is where we reach the maximum, and then it stays there pretty much forever. I didn't change the final value. The dilation starts small, goes up and then down, it goes down again. So I've started it at 1, goes up to 15, and then down to 1 again. Over this strain scale at 3.5 times 10 to the minus 3, it's reached its maximum and then it decays from there. The tensile response initially starts up there, then it goes down to a residual values. Again, very much like the cohesion, over a much shorter strain set of strain values though. Of course, my elastic properties have to be set as well. You have to have density, so you can work out all the inertial effects, the Young's modulus, and the Poisson's ratio as well. And then I've got to set these, as we mentioned, we have separate properties for the roof and the floor as well. So these are actually going to be closer to 10 or 20 MPa. Oops. And these will generally have lower Poisson's ratios as well. I'll keep them the same for now. And of course the density is going to be higher. Okay, ideally we would interpret these from the strength test results. And that's quite an exercise in its own right, and it's worth actually going through a tutorial on that, but we don't, since this isn't a real situation, it doesn't make much sense to actually manufacture data and then interpret it. So let's just assume this is the data we've been given, we've interpreted it, and this is the best set of values it gives us. And then we'll play with the values later on as well. So the last thing I have to do here, of course, is to run this so that it creates this. All this does actually, by the way, is create the variables. It doesn't actually assign anything, or it creates the tables and the variables, but it doesn't actually assign anything at this point. And to do that, I'm again going to steal existing code, which define assign properties, obviously enough. And I'm going to copy this entire piece, I think. I'm going to do it in a separate routine because why not? Fish define assign properties. So I'll just go through it and see how applicable it is. Zone C model assign strain softening. That's the material type I want. Yes, but I want to add something as well here because remember earlier on we set this flag. We set flag elastic. So if the flag is elastic, we don't want to do all the strain softening stuff. If it is elastic, then we just want elastic properties. So I'm going to say, let me actually copy that variable so I don't get it wrong. This is in fish space now, so I can do that. If flag elastic, wait, no, there's an easier way actually. What I'll do is I will assign all the elastic properties before we get anywhere else. So this is quite a complicated range that's involved here, but I'm going to take all of this out. That was the previous one, so all I have to do is say coal. Okay, I'm getting away from myself now. Excuse me. Density, Young and Poisson. Okay, there we go, range union. So this is what I'm going to do before I do anything else anyway. So zone, actually let me use this, I'll just change it. So zone C model, assign elastic. Range group col, let me see, I'm kind of figuring out the logic as I'm going along, that's why I'm jumping around, so please excuse me. What I'm going to do, regardless of anything else, is assign elastic properties to the roof and floor. So let me do that. Zone C model, assign elastic range group roof. Zone property density value Young, Poisson, etc. Range, and then I'm going to steal this. Range group roof. So, and I'm going to use the search and replace again. Well, from your perspective for the first time, but trust me, I did use it before. Replace it with col, and then replace all in the selection. And you see that works out quite nicely. Oh, sorry, I meant to say roof, not col. So now I'm actually replacing col and replacing it with roof. Replace all in selection. There we go. Okay, so E roof is specified there, new roof is specified there, and dense roof is specified there. Okay, great. Okay, I'm going to do exactly the same thing now for the floor. And in this case, I'm not going to look for the damn underscore. I'm just going to say if anything there says roof, replace it with floor, because I've got strings I need to replace as well. And yeah. Oh, I didn't do my replacing here properly. I need to replace col with floor. There we go. Okay. Now you see how useful this double just selection checking is. I saw immediately that when I selected there, nothing lighted up over here, so I could go and fix it up. So you see I've kind of gone away from my convention where I had my roof floor set up as strings rather than as names in their own right, but it's not going to matter in the long run, so I'm going to take a chance and just leave it at that. So, okay, so this is what you're going to do. You're going to specify the elastic properties for the roof and floor regardless of anything else. Now I can go if, after that end command, I'm back in fish space, if flag elastic, and again I will copy. You'll see now the indenting isn't quite right? Well, this Notepad++ is very useful. You select the whole thing, press Tab to indent further, and Shift Tab to indent backwards. Very, very useful. Okay, so I've only got one group I need to worry about here. And now I'm going to replace the word roof with col within the selection, replace all done. Okay. So now I know that's going to work for the elastic case. The model will be pretty useless actually with elastic properties, but it's worth demonstrating this. Then I put else. So if flag is not elastic, then I go and do everything between this else and the next end if. I'll just indent this. So zone C model assign. Let me actually take this, use it as my template. Assign, but here I'm going to copy this. This is now strain softening. Strain softening, range group col, zone properties, so my elastic properties are set. And now From here, I'm going to set the nonlinear properties. So zone property cohesion, blah, blah, blah. So zone friction. And I just have to replace this range union, blah, 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 with range group col. Range group col. Done. Okay. So you see there's two operations here. First, I'm saying the cohesion, the friction, and the dilation and tension, these are the initial values of these properties. So I set them here. And believe it or not, you have to do this. If you just say the table, it won't adopt those initial values for some reason. Or, well, not for all the models anyway. I don't know. It might work for this one, but I'm not going to take a chance on that. So range group col. So what this does, zone property, table cohesion. Table cohesion is a FLAC 3D variable it says what is the name of the table that you're going to assign here. And you can probably see without me having to tell you that those names are all wrong. They are now col, co, col, fric, col, dil, col, tens. And instead of doing search replace, I'm just going to line everything up like that and then go col. There we go. And now all my strain softening properties are set. In command, and if, and in the routine. And of course, let's not forget, we have to run the thing as well. Assign properties, lekker. All right, next, do we have time to actually assign the constraints? There we go. Again, I'm going to copy all of this from another routine. Now, I mentioned in the scenario that, of course, we've got quite high K ratios. So we need to actually initialize those K values, or we need to put an initial stress into the problem. Maybe we'll do that as a second round, actually. Let's just do it without the initial stresses initially. I have my reasons, which I'll explain later. So here's something I can use directly, as we discussed hopefully in the lecture. Zone phase supply velocity normal around x, y, and the lowest z point, I'm just going to apply constraints. It's constrained all over the place, and then at the top okay, range position Z. I don't actually have to. So here what I've done, sorry, let me get rid of that. Here what I've done is I've actually looked, instead of using a single range, I've used a range with a very small value added, subtracted, and a very small value added. That's to ensure that I get the right position. But because nothing has moved in this model yet, I don't necessarily need that. But you know what? I'm going to keep it because just because it's a reasonable example. And I'm not sure why I've done this. It's to create a group. It's a face group that I've created. The top surface of the model, basically. Put it in slot bits. And that is going to be useful probably later. Now, zone phase supply velocity normal. So what I'm going to do later on, though, let's just do it, keep it simple for now, is that I can apply stresses that correspond to the situation at that depth, or nearby to that depth, so that I get some horizontal stresses included in the model. But you know, in an ideal world, I would include the entire piece then of that block and then excavate it, so I could see if that had any effect. Anyway, getting a bit off topic now. Let's do it without the horizontal stresses initially. So zone face, this is where now at the top of the model I'm applying a velocity, which is going to act, going to push downwards basically. Top val is a negative value, so it'll push inwards. Negative means where you use this particular constraint, velocity normal. A negative value means pushing inwards towards the solid. If it was positive, it would be pulling, basically. I could also use velocity z, but it's not going to make any difference, to be honest. And now you'll see I've used this face group right here. Okay, time for another break.